Good morning, dear students. Welcome back to the class. So, continuing with the chapter Light of Physics, we'll see today about the formation of different type of images by a concave mirror. So, the different type of images can be formed by a concave mirror by changing the position of the object from the concave mirror. So you know that when an image is formed, an object is required to form the image. So when the position of the object will change, changing position of the object will give us different kind of image. Okay, that's what we are going to see now. So image formed by a concave mirror when the object is placed at infinity. Infinity means far away. So, which object is placed at infinity? Sun rays. Sun is considered as being placed at infinity because it is very far, isn't it? So, what will happen then? When an object is placed at infinity, the two rays AB, you can see the ray AB which is coming parallel to the principal axis. How is it coming parallel to the principal axis? This is the rule of the image formation we have studied. So, ray AB which is coming parallel to the principal axis after reflection will pass through the focus, that is the point F. Same way we will consider one more ray DE which is coming parallel to the principal axis. After reflection it is also passing through a point. Even if I consider some other rays, let it be K, let us say a ray KL is coming, and then again what will happen after reflection will pass through focus. So that's what it is said here, and intersect each other when all the rays after reflection are intersecting at a point. Principal focus of the on the principal axis. Therefore, in this case, the image is formed at principal focus. So what we say, when the object is at infinity, image is formed at focus. Okay, principal focus. And what is the nature and characteristic of the image? Image is diminished. Diminished means very small. Actually, here we can say it is a point sized. It's not very small, it is point sized. And since it is formed on the same side of the mirror, so it is real and inverted. Whenever it is formed on the same side of the mirror, it will be real and inverted. That's what it is said here. The image is formed at the principal focus. Highly diminished means very small, like a point, real and inverted. Second case, when the object is placed beyond the center of curvature. If this was my concave mirror, this is the principal axis. Okay. Now, for the first case, it was placed at infinity. Then you have the center of the mirror was called a center of curvature, isn't it? This was the center of curvature, and this is the pole, center of the part of the mirror which is considered, and between them exactly midway was our focus, isn't it? These all things are already told. So now when the image object is placed beyond the center of curvature, somewhere here, let us say somewhere here, that is what. So when the object is placed beyond the center of curvature, then a ray of light AB, this is the ray of light AB, which is parallel to the principal axis, and the other which is parallel to the principal axis after reflection. When it will strike the mirror, it will be reflected. So after reflection, it passes through focus. This is the first rule. And the another rule was when a ray of light passing through AE passing through center of curvature. When a ray when an incident ray was passing through center of curvature, then also it was reflected back, but it was reflected along the same line, isn't it? Means it is coming from ACE and going back to AECA, and both the rays are getting intersected at a point. This is the point of intersection. Give it a name, A dash. And then from the principal focus, this is your principal axis, you join this, you will get an inverted ray. Actually what it says, if this is your concave mirror, this is your F, this is your C, and this is your P. These all things you have to learn. So there is no shortcut. You have to learn, you have to practice. So array, and this is my object. Let us say the name of the object is AB. We only consider two rays for image formation. That is also discussed. So first case, when a ray of light coming parallel to principal axis, this is your principal axis. This is your principal axis, parallel to principal axis. After reflection, will pass through focus. This is the second case. Oh, just a minute. It's placed at C. We are not going to place the object at C. It is beyond C. So let me do it again. This is your mirror. This is your C. This is your F, and this is your P. See that this distance from CF will be equal to FP, and the object is placed here. A, B. Then a ray of light passing parallel to principal axis after reflection will pass through focus. That is the first rule. Okay. And the second one says when a ray of light passing through focus after reflection will become parallel to principal axis. So you can see both the rays are meeting at a point. So from here only you will join to the principal axis. Now this part, this was the head. So this is A dash, this is B dash. AB is your object and A dash B dash is your image. These all things you have to remember, you have to practice, then you will get them. Okay, so that is what it is saying. Between the focus, now where is your image formed? Image is formed between focus and center of curvature. And what is the nature of the image? How is it looking to you? It is smaller, isn't it? So the nature of the image formed is that it is diminished. Diminished means small, smaller than object. Real and inverted. Inverted so you can see, and real because it is on the same side. Third case. So actually we started from infinity. Okay. We started from infinity, then we came beyond C. Second case, we placed our object beyond C. For the third case, we are placing on C. Okay, so look here. When the object is placed on C, the first case, a ray of light parallel to principal axis after reflection will pass through focus. Second case, a ray of light passing through focus after reflection will become parallel to principal axis. Both the rays will meet at a point, intersect at a point. This is the head of the image. Give it the name A dash. Join it. This is your A dash and B dash. Now what can you conclude from here? So when the object was at C, so that image is also formed at C. Size of object is equal to size of image. Okay, and the image is real and inverted. That's what you can see. Which other mirror gives size of image equal to size of object? Tell me. You can tell. Send me the answers. Okay. Now you have seen one very common mirror is there. I am not going to tell you the name. Moving on to the fourth case. Now we are coming between C and F. Remember, we started from infinity, then this was C, then we were beyond C, our object was placed. This was the first case when the object was at infinity. This was the second case when the object was beyond C. मतलब C के पीछे था. Okay. Third case we came at C. Now fourth case, this was your F and this is your P of the mirror. So third case at C you studied. Now fourth case between C and F. This is your fourth case. Now what is happening when the object is placed between C and F? So from the head, a ray of light passing parallel to principal axis after reflection will pass through the focus. Second law, a ray of light passing through focus After reflection will become parallel to principal axis. Both of them are meeting at a point. That point should be named as A dash. Join it to the principal axis, B dash and A dash. Now here, the object is placed, where is the object? Between C and F. And where is the image formed? Image is formed beyond C. Remember, beyond C. C के पीछे की side. That's what you have to remember. And what is the characteristic? It is enlarged. You can see it. Enlarged means big. And the other thing, real and inverted. So all the cases for the concave mirror are giving you real and inverted images. Only one special case is there. Please look there. So the image formed in this case is beyond C, enlarged, real and inverted. Fifth case. So we started from infinity. We were beyond C. Then we came on C. Then we came between C and F. Now we are at F. When the object is placed at principal focus, then what will happen? Please look here. So the object AB is placed at principal focus. The first rule says a ray of light passing parallel to principal axis after reflection will pass through focus. This is clear? Okay. Second rule is a ray of light which is coming from center of curvature will follow the same path. Here, even this point is your P. Both levels there, a ray of light which is passing through the pole will follow the laws of reflection and pass with the same angle. So if you see all the lines are parallel to each other, then what we say? We say when the object is at F, images, they are never going to meet. So image is formed at infinity. This is actually the reverse of the very first law. When the object was at infinity, image was formed at focus. Now when object is at focus, its image will be formed at infinity. Okay, that's what it is said here. When the object AB is placed at the principal focus, then the parallel ray of light AD passes to the principal focus F, giving us the reflected ray dx. And the second ray of light AE passing through the center of curvature is reflected along the same path, forming the reflected ray EY. In this case, what is the nature of the image? Image formed in this case will be highly enlarged, infinity, very big. So highly enlarged and real and inverted. Clear? Last case, when the object is between F and P. Actually, they are not showing the P. P should be shown everywhere. So you have the practice of showing your C, F and P. P is the middle part of the mirror. Okay. So now when the object is placed between F and P, now what will happen? So let us consider the head A. I am talking the head part as A and B as the tail part. We are only taking the image formation from the head part. So ray of light passing parallel to the principal axis after reflection will pass through the focus. This first point is clear to you. Second, a ray of light which is going through center of curvature will pass through the same, will come back on the same route, same line. So when you will extend these two rays, now you will see they are never going to meet. Actually, they are going to be apart, moving apart. Then what we do for the image formation, we extend the line YA on the back side of the mirror and XD also on the back side of the mirror. Then they will meet at a point. Wherever they are meeting, that is your A dash and B dash. So this is your image. This is a very special case for concave mirror. Because here only now what is the characteristic of the image? Can you see it is large? So image formed is enlarged, that's what you can see, but it is not on the same side of the mirror. This is the same side of the mirror, this is the opposite side of the mirror. So here it is on the opposite side of the mirror, so it is erect. Whenever it is formed on opposite side, it is erect. same side, when the image was formed this side, it was always real. So this is erect and it is, once it is erect, it is virtual. Erect means say straight, isn't it? Inverted, this was your inverted image and this is your erect image. And real, when it is on the same side of the mirror, it is real. When it is on opposite side of the mirror, it is virtual. So this is very important part from the chapter light, my dear students. Please go through the book, see the notes, practice yourself. Now this is the table which is giving you a nutshell of whatever we have studied. So position of the object at infinity. When the object was at infinity, I told consider sun. So all the rays from the sun, that's why sun is also drawn like this, showing all the parallel kind of rays. So that image is formed at focus. Image is highly diminished. Highly diminished means it was point sized. Isn't it? This point size word is also there. Real and inverted. Second, beyond the sea. So the image was formed between F and C and it was diminished. Diminished was small, real and inverted. And C, so image is also formed at C, same size. I asked the name of another. So today you learn concave mirrors also give same size image. One more mirror is there. So the characteristic is real and inverted. When the object was between C and F, image is formed beyond C. So if you see, I will tell you the technique. So when the object was beyond C, image was formed between F and C. When the object is between F and C, image is formed beyond C. Can you see the relationship between both of them? That's what. Same way, there is a relationship between these two also. Means both are opposite of each other. First and last. When the object was at infinity, image was formed at focus. So when the object is at focus, image will be formed at infinity. The image is highly enlarged, very big, real and inverted. The special case was this. Only for one case it is giving the virtual and erect image. When the object is between pole and focus. Clear, my dear students? So now you have some uses of concave mirror. As you know that concave mirror actually the uh, converging mirrors. Okay, and they give you a for the special case, last case, they give you a enlarged image on the other side. So when you need a big image, what you do, that's how it is used. What are the uses? Concave mirrors are commonly used as shaving mirrors. Because shaving mirror, you hold the mirror very close to yourself and the image of your face looks bigger. So image is formed which helps in smooth shading because you can see the smaller things little big. Concave mirror is used as reflector in searchlights, headlights of motor vehicles, solar cookers, torches and in table lamps. Okay, and last one by the doctors to examine the retina of the eye, ear and throat. So these are the uses of the concave mirror which you should learn and you should know. Please revise, please practice whatever is taught. That was all for today. Now here you have some questions. Define principal focus of a concave mirror with figure. The answer was already given to you. One numerical is there. Radius of curvature of a spherical mirror is 30. How much is that? Every time I am giving you this concept. This is your C, this is your F, this is your P. So then what is the relation? This was called your radius of curvature and this was called your focal length. That was all for today, my dear students. Thank you. Have a nice day.